from India. So I'm just going to finish my thematic points and we'll pick it up here. Is first you need political will and you need visionary leadership for Make in India and for smart cities to come about. What is your city going to be about? What is the soul of a city? The cities are great because they have a soul. Maintain the soul of the city and then transform it. What is it? The second one is you need to have global standards. You can't think about local thing because as all of us in the IT world knows, the reason why our Google software technologies are cheaper or Amazon is cheaper or IT from IBM or Cisco or anybody else is cheaper is because we scale over a huge population. So your solutions for two cities should be similar, but no two cities have the same processes for water management, for disaster recovery. So you need to have standards that are important. We'll talk a little bit more about standards around sensors and electronics. You need smart regulations. Our regulations are not designed for the digital world. They're not even designed for the mechanical world in cities. So you need to have the way and wherewithal to change regulations to design it for using cameras in a very new and interesting ways, using sensors differently. The next two are probably the Achilles heel and also the strength of India. Fourth and the most important is there's not a single country in the world, and India is not an exception, there is not going to be a single smart city built on government money. There is no money in India. Venkaiah Naidu 2 days ago in front of us said, there is no money, we can do feasibility studies that should be driven by public-private partnerships. And they have to be good public-private partnerships, not the models that we have had historically. And the last one is you cannot have a smart city unless you have a local innovation engine, ecosystem that is locally driven, local applications, local API builders, local middleware builders that deploys these, transforms it in a city, and then scales it. We need these five, not 4 out of 5, all 5. You have that in India, at least the ecosystem engine. We need to work on the first few. And that is where the government is kicking in on thinking what the government ought to do. So that's the way of introducing my group. And I'm going to start and have Apparao discuss a little bit about his entire focus from a sensor point of view and what Centum has done, and then we will take each of us and then we'll come back and have a discussion. Is that?
Oops. Obviously, this has been a good morning. All of you are still here and awake, and thank you for being here. It's a real pleasure to be here this morning or this afternoon. And share a few of my thoughts. First, I thought I'd explain a little bit about Centum and what we do as a company. We were established in 1994, and today Centum is the leading ESDM company with about 1,500 people and is listed on the Mumbai and National Stock Exchanges. With 4 manufacturing plants in Bangalore and another major one coming up in the aerospace park at the airport, Centum has all the necessary systems and certifications in multiple domains. The R&D facility is recognized by DSIR, the Government of India. With 80% of our revenues coming from export sales, Centum is the only ESDM company which has received the honor of being recognized as Global Growth Company by the World Economic Forum in the year 2014. Our customers are Fortune 100 companies in the defense and aerospace, industrial, communication, and medical markets. So that's a very brief about who we are. I just thought maybe we should talk a little bit about what smart cities are all about. And I think Anil set the stage for it. But what I'd like to do here is actually take a specific example and a real life example to see how a smart city, what does it really mean? And this is a real example. There is a major water utility company serving the greater London area. They have 14 million customers and 30,000 kilometers of water pipe. One of the challenges faced by them to ensure a reliable and safe supply of water to customers while managing the leaks or bursts that could both interrupt the service and result in significant water loss. It could take hours or even days before a burst can even be detected and fixed, while a smaller leak could go on for months before being noticed or turning into a visible burst. Bursts often severely impacted the local community, as water-damaged homes, businesses, and underground electrical and communication systems forced businesses to shut down, create traffic problems, and resulted in insurance claims for damaged property and lost revenues. You know, when we see water running off on the street and we say, oh, that's a lot of wastage, but actually the wastage is just not water. There's a lot more to it. To save the wastage of water, a scarce resource, they put a system in place to make the whole network a smart network. They implemented a system which predicts water wastages either through leaks or bursts or for any other reason and sends a warning so these can be fixed before the damage is done, saving millions of liters of water and, of course, money. This case gives you a small example of a smart water network in a city. The way this works is you have multiple layers of technology. One is, it starts with the sensor and control technology, working in tandem with information and communication technology and, of course, analytics. These are the kind of technologies or bundling of technologies that play a part in building smart cities. Now, I'd like to talk about how companies such as Centum can play a role in this smart initiative. In Centum, we actually design and manufacture systems for missiles, satellite payloads, RF power amplifiers, measurement systems, power supplies, and so on. These are actually fairly large systems. While we design and manufacture these systems, we also design and manufacture the key components for these systems. In the context of today's topic, some of the key systems or components in making a smart city are sensors. And we design and manufacture these complex and sophisticated sensors. At this point, of course, the sensors we deliver are essentially for space, aerospace, and defense. One of the products we developed is an acceleration sensor. This is just an example of how the technology is and how we can migrate from one to another. One of the products we developed is an acceleration sensor, which was used in the Mars orbiter mission very, very successfully. Mr. Kiran Kumar, the present chairman of ISRO, who at that time was the director of Space Applications Center, called us for a meeting to review the technology and the processes that we used to develop this product. After the review, he asked us as to what else we plan to do with the technology that we had developed. And at that point, of course, the answer was, yeah, well, we'll use it for space and aerospace applications. But with him prodding us and with a lot more help in terms of thoughts and ideas, we figured that we could use the same technology platform to develop seismic sensors which can be used to predict earthquakes and creating smart cities. I also know there are many institutions such as the Center for Nanosciences of Engineering at Indian Institute of Science, and they are developing sensors, MEMS-based sensors, and other kinds of sensors. And I'm sure there are other organizations in India who have the capability or building capabilities. The point I'm trying to make here is that many of these technologies are already available in India, which is what Anil was talking about. The ecosystem does exist. And these systems are also made in India, and that ties into the Prime Minister's Make in India initiative. The challenge, though, and I think, again, Anil talked about it, the challenge here would be how to make these technologies cost competitive for mass production for applications such as smart cities, which I think, and I feel confident that that can be achieved. However, I think the bigger problem is companies would hesitate to make these investments without proper economic and business model. And again, if it's government, the government has no money, and if it's a public-private partnership, I guess the business model needs to be very clear. So in conclusion, you can imagine our cities becoming big. Can you imagine our cities becoming bigger and bigger in the conventional manner? Can you imagine the chaos this will create? I don't think we have an option but to build smart cities. I feel technologies exist to realize the concept of smart cities in India. Also, the government's focus is on developing smart cities and also making the existing cities smart. So I'm confident that it is only a matter of time when different pieces of the puzzle will fall in place in creating a smart city. Thank you.
Thank you, Appa. The point that you made at the end, and I'll turn to Brian Gershon from PMC to add to that, is the whole notion that you have sensors. Sensors have to be connected to some form of a systems, and then we'll have the IBM point of view on how does this all come together, whether it's in the cloud or in a network basis for analytics. But you made a very important point, which is it'll take some time. But just as a way of putting reference and context, 10,000 people are moving from rural areas into a city on a daily basis in India. Daily, 10,000. That means you have to build a new Chicago or a new San Francisco every month for the next 36 years, just to keep up with the expectations of urbanization from 31% to 50%. So we do have to have time, but we're also running out of time in some ways. So we have to think about how do you scale smart cities in a way that we can replicate and do it very much, which is where the systems thinking comes in. So Brian, if you would come in and give us a perspective on how do these things come together in an infrastructure basis, starting from sensors above.
Great. Thank you. Let me start by saying what a pleasure it is to speak here today. I've really been impressed over the last 2 days in terms of the kind of the energy and the passion that I see in the discussions. I think it bodes quite well. Just a little background on myself. I'm kind of a propeller head. I'm a technologist, true and true. I'm a semiconductor guy. And one of the exciting things about the Internet of Things and the opportunity in front of us is there's lots of good technology problems out there for us to sink our teeth into. And I think it bodes well for India because there are excellent technologists here. And so it's a greenfield area, I think, that you can capitalize on. PMC, I think a lot of people see us as a semiconductor company, but really we're a solutions company in the infrastructure space. And really our mantra right now is the moving, transforming, forming, and storing of data. And I think that resonates quite well with today's topic because that's really what it's going to be is taking that data from sensors, actuators, from things on the edge, and then moving in that and transforming that, and then ultimately back into the back end where people can provide software, analytics, and differentiating features. So there's lots of place to play here. So our connection really as an infrastructure company to IoT is quite obvious. And it's interesting. Another reason for my trip is I've come out to celebrate a 10-year anniversary with my team here in Bangalore. And as I've gone through the retrospective of a look at the comms business, and some of you that have been in the industry a long time know that around 2000 we had a huge amount of exuberance and run-up in the comm industry in terms of what the potential for the internet was. It didn't come to be, and largely because there wasn't the applications, there wasn't the driving force behind that at that time. And we had a bit of the telecom bust at that time. And looking at it with the benefit of perfect hindsight, I can see now that the thesis wasn't wrong, it was just too early. And what we're seeing today with the Internet of Things and smart cities and ultimately the smart planet is the ability to combine sensors, actuators,